I don't care whether it's high nutrient profile or low nutrient profile. As long as it's consistent, I can place a value on it. I can use one of the least cost formulation systems, compare it to the other materials that I have available for a particular animal that I'm trying to feed.
Hello everyone, my name is Doug Corver and I'm one of the hosts of the Poultry Podcast Show. Welcome to our latest installment. If you find this interview interesting, please let us know by visiting our website at wisenetics.com. You can also learn more about all our podcast segments covering poultry, swine, dairy, beef, feed milling, and pet food. And you can feel free to suggest a new guest as well. Our guest today is Martin Smith, and he is currently Global Strategic Marketing and Development Manager Monogastrics at Evonik Animal Nutrition. Welcome to the program, Martin.
Hi, Doug. Good to be here.
Yeah, thanks for joining us today. I think a lot of people in our audience might be familiar with you from your frequent and insightful participation in various industry-related online forums. But let's start with a little bit of background information on yourself. How did you first become interested in poultry?
Well, when I left university with a degree in marine zoology, I really wanted to go and count shrimp in the Bahamas, but unfortunately that wasn't possible. So I kind of fell into the agricultural sector and started work for an animal feed company in the UK. And I've not really managed to escape ever since. So I have a background that covers all livestock groups, but as time has progressed, I've increasingly focused down on poultry. So I've worked for a number of supply companies in a range of different materials and products, but almost always the primary focus has been the chicken, both the laying hen and the broiler.
So marine biology, that's a little bit of a switch for you. How have you found that? Have you been able to use some of the basic science that you've picked up as in a unique way, maybe?
I mean, we've done a little bit in aquaculture within Evonik, and occasionally it has proven to be useful there. But by and large, it gave me a grounding in the basics of biology, which then I could build upon as time went on. And I like to think that most of the knowledge and the skills that I have been built on the job with experience in the real world, which I think is valuable.
Now, how long have you been at Evonik?
I've been at Evonik for 10 years now. I came back to them in 2014. I did spend 8 years with a predecessor company called Degussa. So some of your listeners and viewers will know Degussa. And I spent 8 years with them as well. So in total, actually, with the company, 18 years.
So let's talk about what you're currently working on that really intrigues or excites you.
At the moment, there are so many challenges that present themselves to actually all of our livestock farmers. My focus all through my career has actually been helping particularly the farmer colleagues that we have in extracting the maximum value from products and services that they're actually using. And I still feel this is an area where a lot of work still needs to be done. A lot of people will use materials, will use products, will use services, but still not absolutely extracting the maximum value from them. And I think one of the major focuses that we have going forward is to try and identify those areas and help our livestock farms really get the most from everything that they do. I've literally just started a project in the last couple of months looking at anti-nutritional factors. And we begin now to build up a picture of the costs this brings to the industry. Some areas are well known to the industry, others less well known. And what we're trying to do in Evonik is begin to think about how we can bring all of these things together under one umbrella and look for solutions for all of these materials.
Evonik Animal Nutrition is committed to ensure food security and safety while reducing the ecological footprint of animal farming. Its products and services use evidence-based solutions that seek to promote animal welfare and reduce reliance on natural resources. All this is underpinned by long-standing industry partnerships and deep customer understanding. Evonik's focus on efficiency, sustainable, healthy nutrition, and collaborations with livestock farming partners creates value for customers and consumers.
I really like that term, farmer colleague. I think it conveys a different philosophy than a customer or a client or someone who just buys your product.
Absolutely. Many of us are familiar with these concepts about us being links in a chain. So the link going all the way from the crop that we harvest, we process, we feed to our animals. We take the animal to the slaughterhouse, and then we present something to the final consumer. So these are links in the chain, and it's a collaborative effort. If any one of those links breaks down, the entire chain disintegrates. And yes, I have customers. We all have customers. But really, I view it much more about these links in the chain.
One of the topics that we discussed ahead of time was guanidinoacetic acid. And so what can you tell me about guanidinoacetic acid?
Well, I started work actually on guanidinoacetic acid in probably about 2008. And within Evonik, or Degussa at the time, I did some of the original trials, one or two based in the UK. So guanidinoacetic acid is a molecule that is commonly found in animals, in terrestrial animals and in fish. And it works primarily in the body as a precursor to creatine. So guanidinoacetic acid can be manufactured in the body from arginine and from ornithine. The process then creates guanidinoacetic acid, GAA, and then with the addition of a methyl group, this is converted to creatine. Creatine is an extremely important molecule in terms of energy metabolism for all animals, including humans. I mean, most of us will be aware that athletes and people like that will take creatine hydrochloride as tablets, and it's known to be something which boosts performance for runners and people like this. Within livestock, it has a crucial role in a reservoir of high energy phosphate groups that allow each of the cells then to generate the compound called ATP, which is the currency of energy. This then allows the cell to utilize all of the nutrients which are supplied through the bloodstream from the feed which we give the animal, and then construct more cells and expand the size of the cell. In other words, to grow. And what we found was that often there's a limitation in the quantity of creatine that's actually available to the animal. So this poses then a limitation on the rate of growth. So we can provide all the nutrients, the amino acids, the trace elements and the minerals that we want for the animal to actually grow. But if that limitation in energy at a cellular level is there, then this is the block and doesn't allow the animal then to express its true genetic potential. What we found was if we added GAA into the diet, this could then be converted into creatine, and this barrier for performance was actually removed. So, for example, the addition of guanidinoacetic acid to the diet of a broiler chicken will increase growth rates. The chicken at the end of the cycle, so a typical 35-day cycle for Europeans, I appreciate North America is a bit different, but typically for the bird there, we'd see an extra 50 to 60 grams of live weight. We'll probably see something 12 to 15 grams extra breast meat. And probably most importantly is that we'll see an improvement in feed conversion ratio of between 2 and 4 points. So the quantity of feed required to produce that chicken in the first place is reduced, which means we're doing it in a more cost-effective way. We're saving money in terms of feed costs whilst producing the same amount of chicken. The alternative approach is to view the fact that because we are actually utilizing energy sources in a more efficient way, we could actually reduce the energy content of the feed and still expect the chicken to perform in the same manner. And in this scenario, we can then basically give the guanidinoacetic acid an energy value. And typically the energy value that we would give it is between 50 and 100 kilocalories. per inclusion of guanidinoacetic acid in the feed. And again, what that will do is reduce the cost of the feed whilst maintaining the performance of the bird.
So conceptually, maybe is it like adding enzymes where the enzymes themselves don't contain the energy or the phosphorus or what have you, the nutrients. They potentiate the nutrients that are already there, and the guanidinoacetic acid itself, the energy value is maybe relatively small, but it potentiates the liberation of energy that's already in the diet.
That's exactly the right phrase, Doug. Potentiation or improvement in the efficiency of capture. I would make a small point that there's quite a big difference between enzymes and guanidinoacetic acid. Enzymes act very much in the gut of the animal. So what they're doing is they're actually enabling the molecules in the feed to be broken, or the compounds in the feed to be broken down into smaller and smaller parts, which are then more easily absorbed by the gut wall. Whereas guanidinoacetic acid, having been transformed into creatine, is actually acting at a cellular level. It's acting within the muscles of the animal, and that means actually that these two concepts, the concept of improved energy utilization because we use an enzyme, and improved energy utilization at a cellular level, could actually be additive. So we could see a scenario where somebody effectively is using a non-starch polysaccharide enzyme, liberating the potential for energy there, and then the guanidinoacetic acid, through its conversion to creatine, is allowing the capture of that energy.
So it basically increases the amount of net energy, getting closer to the gross energy content of the diet.
Yeah, exactly that. Now, there is one thing to say here that might and sometimes does form another limitation. So I've explained that guanidinoacetic acid itself needs to be transformed into creatine. And this requires the addition of a methyl group. And methyl groups, in some situations in nutrition, can actually be a limitation. So the majority of methyl groups that we will find available will be coming from an amino acid called methionine. And in situations where methionine is limited, which we do find in some situations, then that means the conversion of guanidinoacetic acid into creatine could itself be compromised. And obviously one of the important things that we need to do, again, going back to what we originally talked about maximizing value, is really understanding, as well as using guanidinoacetic acid as an effective tool to improve energy utilization efficiency, we also need to make sure that the methionine content is also adequate to ensure the conversion into creatine.
Other ways of increasing the methyl donor potential, so choline or betaine or...
Yeah, choline and betaine are often used. I mean, if you look at recommendations from companies like Aviogen, then there will always be a choline recommendation. And for sure, choline and betaine do act as methyl donors. But if you look at the kind of conversion rates in terms of molecular weights, methionine is still the most effective and the most efficient, and by far the largest molecule in the body that acts as a methyl donor. The other thing about methionine is that it can act as a methyl donor several times. So methionine, once it's consumed by the body, actually gets recycled. So it goes through a series of steps, homocysteine, etc., and it can donate its methyl group several times before it then gets incorporated into the structure to basically become muscle.
So guanidinoacetic acid is a metabolic intermediate. There's precursors and there's the final product that's used in the body. So what's the advantage of supplementing guanidinoacetic acid relative to just adding more of the precursors to the diet?
Okay. The first thing to say, sometimes some people say, well, why don't you just add creatine? Which would be a very logical thing to do. The problem is that creatine is not a stable molecule in terms of feed production. So any time that we face a situation of producing feed and using heat to produce pellets and things like this, creatine gets broken down. So unfortunately, creatine is off the agenda until we can find a mechanism by which we can protect it from heat damage. Yes, we can add more arginine. But what we find is that by bypassing that process, by actually adding the preformed guanidinoacetic acid, we see efficiencies of production, and we see a more cost-effective way of getting to the creatine that we ultimately want to do. The other side of that coin is that we spare arginine. So arginine is an important amino acid. Okay, it's an amino acid which is used in the production of muscle protein. That's ultimately what we want it to do. But it also has roles to play in vasodilation and a role to play in the production of nitrous oxide within the body, which is a signaling molecule. So again, when we actually formulate using guanidinoacetic acid, we can also give it an arginine value as well, because it's sparing arginine that would otherwise be used to produce GAA.
Thanks. That's really helpful. Coming back to supplementing creatine itself, are there chemical forms of creatine, or is meat really the only practical source of creatine?
We're actually working on other ways in which creatine might be protected. One of them is a chemical method. I guess encapsulation methods might be considered, but I think then we're probably looking at making a product quite expensive and therefore not cost effective for production of chicken and eggs and things like that. Mm-hmm. So I do think that yes, we're probably looking at just guanidinoacetic acid as a compound at the moment. There will be developments in the future, and I think we will see improvements in this. But for the time being, yes, that's what we're stuck with.
Well, and I was thinking in terms also of an application in all veg diets where meat and bone meal, for example, are not used. This
is an extremely good point, Doug. In the past, where meat and bone meal was commonly used, where fish meal was commonly used, some creatine and some guanidinoacetic acid was actually coming from these meat products, and as you're alluding to, vegetable byproducts, vegetable products don't contain any guanidinoacetic acid or creatine at all. Even if we're using meat and bone meal, poultry byproduct meal, meat and bone meal, fish meal, the problem there is that the variability of the content of both creatine and GAA is extremely high. We did quite a lot of work earlier in the process of bringing guanidinoacetic acid to the market, and the variation can be plus or minus 100%. And again, as a practicing nutritionist, as a formulator, your worst enemy is the variable material. And so, yes, it's possible to take account of the supply that might be coming, but with the variation on it, it's a very, very dangerous game to play.
So you alluded to guanidinoacetic acid being used in broilers, and presumably it would have the same benefits in turkeys as well. But are there advantages in other types of production, also in layers or breeders?
We have trials and we've done work with turkeys, and clearly the mechanism is the same. With the laying hen, the demand on the bird is a slightly different demand. I mean, then we're talking about a sexually mature bird. Maintenance requirements for amino acids compared to the requirements for the growing bird are relatively minor. And even the quantities of energy that are required are also very much lower. So we do see opportunities mainly coming from the approach of ascribing an energy value to guanidinoacetic acid. So we do see benefits there. I mean, they're cost-saving benefits, and we can then maintain the levels of egg production and egg size whilst reducing feed cost. Mm-hmm. There is also the fact that we can see increases in the level of creatine in the egg, which for some markets this might be of interest. And then going beyond just the bird that produces eggs for human consumption, we can consider the broiler breeder. Now here we actually see some very interesting and valuable opportunities, which to be honest, we still need to fully explore. The first thing that we've seen is that we see an improvement in hatchability, the improvement in the number of day-old chicks produced per breeding hen. And the theory at the moment is that because we've supplied the hen with elevated levels of guanidinoacetic acid and therefore creatine, this is then transferred into the egg, which we know and we can measure. But then the embryo, as it develops, is actually more viable and is more able to actually break out of the eggshell itself. And so we end up with a day-old chick much more often than we would if we don't use guanidinoacetic acid. There's one trial that we've got where we saw quite astounding improvements in hatchability, but even a 2 and 3% improvement in hatchability, I think, is important and interesting for people. Mm-hmm. The other thing that we've done is we've then looked at the progeny. We've looked at these day-old chicks and followed their development and compared the day-old chicks and the growth of the day-old chicks from birds that have been fed guanidinoacetic acid against those which have not. And what we see is, again, these chicks, their growth rate is much improved, even if we don't feed them any guanidinoacetic acid. And again, the rationale there is that as the chick hatches from the egg, carrying with it the yolk sac, but also carrying with it a higher level of guanidinoacetic acid within the body of the chick. Again, the chick is more able to use those energy sources, both the yolk sac and the feed that it starts to consume. And everybody knows the most efficient time for growth of any animal is when they are very, very young. Their maintenance requirement is so much smaller. Almost all of the nutrients that they consume then go into actual production, growing. And that then follows through right the way through to slaughter. So this is an area which still needs to be fully explored, and that's work that we continue to do.
Yeah, the hatching process itself is very energy intensive. There's
Yes.
a huge metabolic demand, and so I can see that if there's an increased supply of energy available, we're giving those chicks the leg up. But you mentioned that there was also benefits in terms of embryonic development, a positive effect on embryo development and maintenance?
Maybe development might be the wrong word, certainly growth. So we can actually see that because, again, that embryo consuming energy within the shell is actually able to grow at a more efficient and effective rate. I cannot say for certain that I can point to an increase in the weight of the day-old chick. I'm not sure I've got that information to confirm that, but ultimately I would believe that would be a possibility, that we might be able to add 1 or 2 grams to the weight of a day-old chick. And again, the viability of that day-old chick is therefore improved. We might look to see decreased mortality and decreased morbidity in those chicks as they go through the grow-out process.
I'd like to remind our audience that if you find this or any of our previous topics worthwhile and informative, I'd encourage you to subscribe to the Poultry Podcast Show YouTube channel by clicking on the bell icon to receive our notifications. You can also share this video or recording if you learned something new today. Martin, one of the interests that you suggested was a real-time evaluation of feed ingredients, and we talked about variability in feed ingredients previously. Why is it so important for nutritionists?
This really does go back to one of the points I made earlier about maximizing the value and extracting the maximum quantity of value from all the materials we have available. First and foremost, variability really is the enemy of any practicing nutritionist. I often say to my colleagues and to the people I work with, you can give me a material as long as it's consistent. I don't care whether it's high nutrient profile or low nutrient profile. As long as it's consistent, I can place a value on it. I can use one of the least cost formulation systems, compare it to the other materials that I have available for a particular animal that I'm trying to feed, and I can say this is worth $150 or this is worth $200. It doesn't matter, as long as it's consistent. As soon as I've got variation, I have a real headache. What do I do? Let's say, I don't know, the energy content ranges from 2,000 kilocalories to 2,500 kilocalories. Where do I place my matrix value? Should I put it in the middle? Should I take a safety margin and put it here or put it there? What I have tended to do is use standard deviation as a measure of variability, and then I will basically penalize materials which are highly variable by reducing my matrix value from the mean by half of one standard deviation. So obviously, the larger the standard deviation, the more I'm taking energy, amino acid content away from that material, effectively making it less attractive and less valuable to any formulation that I offer it to. If we can develop techniques that enable us to reduce variability by maybe dividing different sources of materials up and saying, okay, this is higher amino acid content soybean meal versus slightly lower amino acid content soybean meal. Again, as soon as I've done that, I can put a real value on this one, I can put a real value on that one, and then I can start to make decisions about how I can blend these things together again to make feed so that I can use up all the material. We need to use the material we buy. And the use of techniques like near-infrared reflectance spectrophotometry, so NIR, which in real time can give you the results about the quality down to amino acid level, or we're working currently on things like carbohydrate content and different types of carbohydrates. All of these things can then be used to really continually update the nutritional values of the material that we're actually using. And as I say, we can actually do this in real time. Ultimately, what we will get to is inline analysis. So there are clear possibilities that we could actually analyze materials as they stream past a detector head, and as they're approaching the mixer, we can then make adjustments to materials that would compensate for deficiencies, or we can remove things. So, for instance, amino acids would be a classic example. We analyze some soybean meal as it goes into the mixer. We find the lysine is a little bit higher than we'd originally anticipated. So that means we can reduce the quantity of lysine hydrochloride or lysine sulfate that we actually add to the feed. We reduce the cost of the feed. We maintain the lysine level. We maintain animal performance. Everybody's happy.
So there's really several steps along the progression. So the first one is we receive a shipment of a particular product. And if we're comfortable with that product and the variation, we know that historically there's not a lot of variation. We're comfortable with it. The risks are less. But I think globally we're seeing more and more co-products and byproducts that can be variable. So then the next step is understanding which products are variable and how variable are they? How do we limit that risk? And then the next step is saying, okay, can we understand not just the variability in a group of samples, but what's arriving at the mill? What is the actual nutrient content? And so you're talking about NIR, you're talking about inline analysis. And of course, NIR is being used globally by lots of different feed mills. Are there any new technologies or new developments in how NIR is used that are really moving us along in getting to that really ideally eliminating variability?
We will never eliminate variability. It's an inherent characteristic of biological materials that they are inherently variable.
So can I just clarify? Sorry, we may not eliminate the variability, but if we understand exactly what we've got, we eliminate the effect of that variability.
Yeah. I would say almost every calibration for NIR that works well is already using this technique called Fourier transform. That seems to be extremely effective. I'm sure experts in NIR spectrophotometry will shout at the screen at the moment, say, no, there's a better technique. And I'm not an expert in these things. I don't derive the calibrations myself. I simply just use what's available to me. So at the moment, I think we've the techniques that we use are as developed as they might be until something new comes along. But what we need to do is extend the range of materials that we can, or nutrients that we can look at. So you know that Evonik have pioneered the use of NIR to look at amino acids. We're continuing that work to now look at fatty acid profiles. So we can use NIR to look at fatty acid profiles. As I said, we're already looking at carbohydrate fractions. So we're now trying to divide the carbohydrates in materials down to non-starch polysaccharides, soluble non-starch polysaccharides, which can then be used again to consider the levels of enzymes that might be used. So again, trying to get to a point where we can make decisions that will actually help to reduce costs whilst maintaining performance. I see no reason why in the future sometime we won't be able to do screening for maybe even mycotoxins and things like this. So these are the approaches that we need to do and to develop the technique. On the other hand, NIR is pretty useless when it comes to minerals. And what would be nice is if we could develop a technique, a similar technique that would give us up-to-date information about calcium and phosphorus and magnesium and all the important minerals, because we need to keep aware of those and balance those. And there's a lot of work has been done recently on, for example, different sources of calcium. I mean, we all think, limestone, wonderful stuff. And then we begin to really appreciate and understand the variability it's inherent in the digestibility of the calcium that's in our calcium carbonate, in our limestone. And we need to try and find techniques to really speed that up and, again, do those things in real time.
Yeah, and that's one of the challenges of moving towards a digestible calcium formulation basis is that variation exists, and it's not simple, certainly in real time, to understand the variation in digestibility of calcium.
We can do, as you say, we can do surveys. We can collect samples from different sources, different quarries, and then we can give values to these things, and we hope that they are consistent, and we can go back and check. But it's nowhere near as good as being able to say, okay, as this material arrives, I take a sample. And an important point I would make here is the sample needs to be representative. Mm-hmm. Again, trying to help people to maximize the value of the things that they do. Just grabbing a sample off the top of a lorry ain't going to work. I mean, what we need to do is have a sample that really represents the consignment of material that's actually just arrived, which needs some planning and some thought. We get the sample, then we analyze it, then we can say, okay, this now really represents a load of material. Yes, I can see everything is okay. Just a small variation here. These are the kind of things that we do need to apply ourselves to.
So that's an interesting transition point. The idea that it's a team of people that needs to work together to understand what the goals are, not simply directing someone to collect a sample, but how does the sample need to be collected, and how do samples need to be handled, and what's the analytical process. So you've worked as part of a global team in your time at Evonik. What are some of the challenges that you faced in terms of dealing with multiple languages or backgrounds or production systems and assumptions? And maybe that's a long conversation. But
see, the first thing that comes to my mind is time zones. I mean, if I've got colleagues in China and I've got colleagues in Brazil and trying to organize a time zone which suits everybody, this is the most difficult thing, because I'll invariably upset somebody because either he wants to take his wife out for dinner or it's a bit early in the morning, he doesn't want to get out of bed. So time zones are actually a practical challenge. But the beauty about working with such a wide variety of different people with different experiences is learning about the different ways in which things actually get done. Sure, we all grow chicken, we all produce eggs, we all grow pigs. But the ways in which we do it across the world are so variable and so different, and trying really to pick up the lessons that we can learn from each other about the best ways that we can do it. And then for me, as somebody that's actually trying to provide guidance, services, products to customers, actually understanding why this material I have here works fine in the United States, but when I present it to a colleague in Indonesia, it doesn't work. And that's, for me, is actually the beauty of this, is I get the opportunity to learn so much about again, variation, about the different ways in which things happen, different challenges. We're very much now at the interface between nutrition and health. And that depends very much on the health challenges that the livestock face in the different parts of the world, and they're different. And they're different because of the environment. They're different because of the management techniques that are used. They're different sometimes because of the animal that we're actually growing. But for me, that's the most wonderful thing about the opportunity of learning. Language is not so much of a challenge because I'm an English speaker. And actually, that Brits are dreadful at learning foreign languages because we basically expect everybody else to speak English. But thankfully, a lot of people speak very good English, so this is not usually a challenge.
So Evonik has a portfolio of products. How do you go about making sure that your products are fit with suppliers of other materials or other products that would end up in diets?
Yeah, and I mean, again, this is this concept about all of us being collaborators in producing the end product for the consumer, and we all have our role to play, and we're all links in the chain. And I very much subscribe to the view that my colleagues that actually go and talk to feed mills and integrated poultry processors or farmers, they need an awareness of the other materials which the farmer or the feed formulator might be using. Because trying to say, okay, my product X is the best product for you in isolation, it just doesn't work. I mean, you have to have an understanding of what else the customer, I've used the word customer, is using. We need to be aware of what his thoughts are about, I don't know, energy content coming from non-starch polysaccharide enzymes. All of these things have a bearing on the best way to suggest to the person we're talking to, the customer, the best way that they can actually use our product. And then we then need to also collaborate. I mean, producers of other feed additives, they don't necessarily compete with us. And I see no reason why there shouldn't be this cooperation and collaboration, because ultimately the person that buys our materials needs to be successful and needs to make a profit. If he doesn't, he's not going to be there, and we lose a customer, we lose revenue, and we lose profit. And we have an absolute vested interest in making sure that the consumers of all of our additive products are as successful as we can possibly make them, because they're going to be there tomorrow and the day after and the day after. And we have a responsibility to look after them.
Natural Biologics is using cutting-edge science to dig deeper into the poultry health challenges you face. By gathering scientific evidence, they identify the most effective combinations of natural ingredients that improve animal health. Visit naturalbiologics.com/poultry to see the newest research in both turkeys and chickens.
So within the context of your team at Evonik, but also the bigger context of other ingredient suppliers and the end user, it seems like consensus is important, knowing what the other group is doing and being able to work together.
I would be not necessarily consensus, but certainly awareness. I mean, the example I used of non-starch polysaccharide enzyme, I chose that example for a reason, because I have opinions about the use of non-starch polysaccharide enzymes, which would not be accepted by the supplier of the non-starch polysaccharide enzyme. If I am aware how my customer views these materials, I might not agree with the way that he's valuing these materials, but if I'm aware, then I can make value judgments and compensations when I come to him and explain what my products might be able to do to help him. So I think awareness is probably closer to it. If we can reach consensus, this is fine. But obviously there are commercial pressures sometimes which prevent us from reaching that consensus.
Well, thank you, Martin. That was really interesting. It was a good discussion, and I learned a lot about guanidinoacetic acid. Thank you also to our audience. I hope you found this informative as well, and please feel free to give us a thumbs up on the platform you're using to view this podcast, and feel free to suggest potential subjects for our future shows. I'm Doug Corver, and I'll see you next time on the Poultry Podcast Show.